Today we're going to talk about relationships between continuous variables and the Pearson correlation coefficient. The main tool for evaluating relationships between two continuous variables is the correlation coefficient. The formula for R takes the product of the deviations of both variables from their means in the numerator and sums these products across all observations. Note that this product will be positive when both x and y are above their means, or when both x and y are below their means. In the denominator, we take the product of squared deviations of each variable from its mean. We sum those products across all observations and take the square root of the sum. We then divide the numerator by the denominator and get the correlation coefficient. It's important to note that the correlation only measures the strength of linear associations. If the relationship between x and y is strong but not linear, the Pearson correlation coefficient will not indicate a strong relationship between the two variables. The correlation coefficient is bound between -1 and +1, with 0 indicating no linear relationship, and the strength of the relationship increasing as you move away from 0 in either direction. One of the first questions people ask is, how big does a correlation have to be good? There's no really good answer here, but there are some rough guidelines that you can follow. We would generally think that correlations between -1 and -0.7 and 0.7 and 1 to be strong. However, there can be meaningful and interesting correlations between variables below the 0.7 level. Here are some scatter plots of data with specific correlations. In the upper left-hand panel is a correlation of 0, and in the lower right-hand panel is a correlation of 1. Note that with a correlation of 0, you should see an amorphous blob of points with no real systematic pattern at all. As the correlation increases, the points start to coalesce around a line. Once the correlation gets to 1, all the points lie exactly along a straight line.